Our goal is to find power series representation for function f of x, which is 1 over 1 plus x. Recall that for a geometric series, if you have the summation of x to the n start from 0 to infinity, as long as the absolute value of x is less than 1, this guy is convergent to 1 divided by 1 minus x. And in general, we found a pattern. The pattern was, as long as you have the summation of a quantity raised to power n, as long as the absolute value of that quantity is less than 1, this guy is convergent to 1 divided by 1 minus that quantity. So our goal is to find that quantity, right? Or if you have 1 divided by 1 minus a quantity, the power series representation is on the left-hand side. Let us rewrite this as rewrite 1 divided by 1 plus x as 1 divided by 1 minus x. So then you can easily see this box. The box is minus x. Okay, perfect. 1 divided by 1 minus x can be written as the summation of negative x to power n and start from 0 goes to infinity. But from algebra, we know that negative x to power n is negative 1 times x to power n. That can be written as negative 1 to power n times x to power n. So this series can be represented as the summation of negative 1 to power n times x to power n. And start from 0 goes to infinity. 1 over 1 plus x is equal to the summation of negative 1 to power n times x to power n. And for the interval of convergence, the absolute value of minus x must be less than 1. This is basically the absolute value of the box, but remember that the box is equal to the absolute value of negative x. So remember that the absolute value of negative x is the same as the absolute value of x. So x must be bounded between negative 1 to 1. So the interval of convergence, I, is open interval negative 1 to 1. So we want to use power series representation for function 1 divided by 1 plus x. We are going back and reviewing what we learned from geometric series. When you have a geometric series, you have a nice pattern. Recognize the pattern and fit that into this pattern. Here, as long as you have 1 divided by 1 minus a quantity, it's equal to the summation of that quantity to power n. But in this case, we rewrote 1 over 1 plus x as 1 divided by 1 minus x, and that quantity is minus x. Fit that into the definition and pattern of geometric series, you end up with the series of negative 1 to power n, x to the n. So basically, 1 over 1 plus x is nothing but the summation of negative 1 to power n times x to power n, and start from 0 to infinity. And for the interval of convergence, the quantity that you had was negative x. But the absolute value of negative x is the same as the absolute value of x. X is bounded between negative 1 and 1. The interval of convergence is open interval negative 1 to 1.